All right, I think it is 3, so we'll go ahead and get started. Thanks for coming. I'm really excited to do this. I'm going to be talking for the next couple of minutes on building a simple command line interface. This was something that seemed really hard and mysterious for me for a little while, and realized that there are at least a really simple way to do this if that's you just want to do some simple stuff. Before I jump in though, I'm really curious to know I want to hear from you. What would be worth 20 minutes of your time? In other words, what can I focus on? What questions do you have up front that I can try to answer so that hopefully this is a really valuable presentation for you?
For me, I'm mostly curious about like kind of the overall like architecture of like what is like the framework to then be like added on to.
Okay. So what is the framework for a command line interface that we can kind of add on to? Okay. What else?
Maybe how to move beyond handling the inputs in if statements into, and maybe this gets into your framework question.
Okay. Yeah, how to move beyond the if statements into doing something else. Okay.
Yeah.
In the back. Okay. Okay. All right. So, so getting data off a device, how might we use the UART system for that and put it somewhere on our host system? Okay. Great. Anything else? Okay. Excellent. In that case, I might end up kind of going through the bulk of the talk rather quickly. The part that was mysterious for me for a little while was honestly the if statements, like what is happening when I type something into a console and my microcontroller does something. Maybe a lot of the questions that were presented just now might get answered when I get to that going further part. I feel like I got a lot of links there. It's a lot of stuff for everyone to kind of check out to go beyond a real basic command line interface to something more powerful. Okay, so command line interfaces, like it sounds like many of us are familiar with, as they relate to an embedded system, a microcontroller can do a lot of things for us. We can control tasks and query the state of the microcontroller from a shell on the device, which is something we'll see today. I can, if I'm bringing up a microcontroller, I can write a small, almost like small REPL in order to interact with the microcontroller and make sure that I've configured peripherals correctly. And maybe I've got an I2C sensor that I'm trying to talk to with a couple of command line instructions. I can instead of programming something and flashing and hoping it works, I can kind of talk to it directly over the console to make sure it's configured correctly. I can load data or get data off my device or upload firmware. On Cortex-M devices, there's actually a really interesting interrupt that allows me to do on-chip debugging over the UART peripheral, which is really cool. And if I really start to carry this idea to its logical conclusion, I can start to develop almost like a small operating system for my microcontroller or a small kind of monitor that lets me run different programs and interact with the device and inspect memory. I've got 2 examples here. You'll see more later that are things we can put on our embedded systems that interact over the UART port and that start to look like tiny computers. I thought Andy Turk had a great quote. This is a random quote that I got from a blog forum. He just said, hey, if I'm starting with a microcontroller, as soon as I can blink an LED, I'm going to try to talk to that UART port and try to get a little command line shell going, which I thought was really great advice about getting a system kind of up and running. Okay, so I'm going to give you a couple of demos really quick. This is one example of a very simple command line interface running on my little STM32 microcontroller. Let me pull up the right one. Okay, and so like you can see from my little message dictionary here, kind of, I've programmed this to respond to 4 basic commands, and I'll see if I can try to hold this up so you can see my little blinking LED up here in the corner that I can control with my off commands. Sweet. Okay, I can turn it back on again. I can change the duty cycle to 10% or 90%. I can change the frequency to something really fast or something on the slower side. Yeah. Okay. So so we'll see today how you might build this just for this system here. Additionally, I've got a little Arduino board here, reading from my potentiometer, and I'm going to show you a little Python script I've written in PyQt, which is displaying live the ADC values coming from my Arduino microcontroller. So we can do more than just kind of interact with these devices from the console. We can actually almost consider this as like a communication system between the microcontroller and our host computer. And I'll let your imagination run wild with all of the things that we could do in PyQt in some sort of graphical user interface with pulling data off the device, having buttons that send data and commands to the microcontroller in order to do all kinds of stuff. Now, this might not seem like a command line interface, but I think it still counts because all this thing is doing, every time the PyQt console sends an R character to the Arduino, it responds with its ADC value. So I can still kind of like get into the shell here and interact with this thing. So there's lots of really neat things that we can do with our command line interfaces, and you'll see how to build those today. The low level kind of and very basic way that we implement these command line interfaces is in 3 steps. So we'll talk about each one. We're going to make sure that we can read something coming over the UART port on our microcontroller. We're going to take that string that we've received and parse it somehow into pieces, and then interpret those in a way that lets us execute something. Okay, so step 1, reading from the UART peripheral. I've got a flowchart here for a very basic program. The top half is my little task that's going to read from the UART port and build up a string. Right now, it's not going to do anything with that string. It's just going to build it up. And then underneath that, I have a little blinky task. And it's important that these be non-blocking, at least as long as I'm not using a real-time operating system, so that I can do both simultaneously. And so on in Arduino, all right, so here's my loop. I'm just checking if there is serial data available. If there is, I'm going to echo it back to the computer because that doesn't happen by default. As long as the character that was received is not the new line or the carriage return, which I'm going to use to sort of signify the end of some command, I'm going to add that to my command string. And as soon as I do receive one of those 2 characters, at this point I'm just going to erase what's in memory. At some point I'll do something with that. And then down here I have a non-blocking way to kind of blink an LED on and off. All right, so we start off with just these 2 kind of non-blocking tasks. Reading a character and then triggering some action when the new line or the carriage return characters are received. On the STM32, at least if I'm using the HAL, I don't have like a serial.available function, which would be really convenient, so I have to do this a slightly different way. The best way that I've found out how to do this is to make an array in memory where I'm going to store the string that I'm receiving over UART, and then to set up the UART peripheral to receive a single character via the interrupt. So I've got my HAL UART receive _IT function, which is going to set up the UART interrupt to receive 1 character. As soon as it receives that 1 character, then inside my interrupt, I'm going to add that value to my array of characters. And then inside that interrupt, it'll set itself up to re-trigger on the next. So 1 character at a time, this interrupt is triggering and adding a character into an array. And only when it receives that new line or that carriage return character at the very end does it set a flag, which I'm calling command received. Sets this flag to be true, and then in my main code, once that flag is true, then I do something with it. All right. So I'm using the I use CubeMX to write this. Okay, so you can see, I'll jump to the main code here, right? This is where I initialize my interrupt. Hey, receive 1 character. When that gets triggered up here, you can see this is where I'm echoing that character back to the console. So I'm using the HAL_UART_transmit function to do that. And as long as I have not received yet the new line or carriage return, and as long as I still have room in my buffer, then I set the interrupt up to trigger again. Once I do get one of those two characters, then I kind of reset some stuff and set my command received flag to true down here in my loop code. Once that flag is true, then I can do something with my string. Here I'm basically just clearing some stuff out of memory, but otherwise we would do something interesting here with that string once we'd received it. And then underneath that is my blinky task. All right, let me get my slides back. One sec. Come on. Okay, so we can receive a string over UART, and at the same time we're doing something else in our code. Let's extend that. Step number 2 is we're going to actually start to interpret these strings. We're going to respond to simple commands. We'll start with just on-off for the LED. And so we're going to make one small change to our flowchart, which is instead of just clearing out our buffer when we finish receiving our string with our new line or carriage return character, now we're actually going to do a little bit of a string comparison, right? If the string matches on, we'll do something. If it matches off, we'll do something else. And so here we go. All right, so in my Arduino code, starts off the same, right? I'm checking if a serial character is available. I'm echoing that character if it is. If it's not the new line or the carriage return, I'm just adding that to my string. And then here, previously I was sort of clearing out the string, but now I'm actually doing a comparison to check if it's on or off. And in the code now, what I'm doing is setting kind of another flag variable. I'm setting an LED is blinking value to either true or false, and I'm using that down here as I'm blinking my LED to control whether that task actually executes or not.
How are you doing that string comparison? Did you override the equal operator?
Yeah, well, so this is in C++, defining this as a string lets me do that. You're right. In C, I have to get a little. I have to use something a little different. So on the STM32 code, you'll see a string comparison. In my main code right here, if string compare is on is equal to 0, then I do something. Yeah. Okay, so now that we can respond to single word commands, we can add some values onto those. And you'll see here I'm extending my flowchart a little bit. And before I process some commands, I'm going to basically look for this value. So the way I chose to kind of go about doing this was looking for the space character. I'm using the space character to separate the parts of my command string. So I decided, okay, if there's a space present, then I'm going to carve up this string into two pieces. I'm going to insert a null character where that space was, and grab a pointer to the beginnings of the two parts of the string, which I called command and args. And that'll let me separate down here when I respond to duty cycle commands or frequency commands. It lets me put the numeric value that comes after that command into its own little string. And then I can continue with my string comparisons, my list of if statements, to see, okay, was the first part of this message, was it the on command, was it the off command, was it the DC command or the free command? And if it was one of the last two, then I can check if there was a numeric argument given. Okay, so here in my Arduino code, I'll show you that real quick. All right, again, I'm checking if a character is available. I'm echoing it once I receive it. As long as it's not the new line or the carriage return, I'm just adding that to my string. Now, once I have received that new line or carriage return, I'm going to check if there is a space, and if there is, I'll carve that string up into 2 pieces. And then here's my long if-else statement, basically. If it's on, do something. If it's off, do something different. If it's the DC command, then we'll check. We'll do something slightly different if there was or was not a numeric value present. Because at least in my implementation, I decided you could specify a duty cycle value with a number, and if you left that off, then the system should report back to you what the current duty cycle is. And same thing with the frequency command. And then I reset the string, and we start all over again. All right, I want to say one thing about carving this string up. So we saw what we were doing, or what I chose to do is kind of manually carve the string up, manually search for the spaces and insert those null characters. It's also possible to use the string token function in the C library, or string token _r. That basically does the same thing. Furthermore, I chose to, because my commands were simple, basically, have kind of two values, my command string and my argument string. Another possible solution might be to kind of follow the argc, argv style of command line arguments, and instead of just kind of carving this thing up into like a first and second, inserting or grabbing a pointer to the beginning of each space separated argument in my command line string, and then reporting the count and the list of string pointers to my program. Okay, so so that for me was like a watershed moment, right? Because I'm seeing folks implement these these command line interfaces here, and I thought there was some magic to it. And it just comes down to once we have this string in memory, carving it up somehow, using spaces or commas or semicolons to kind of separate our arguments, and then string matching, right? String matching in potentially a longish if-else chain to find what's there and do something with it. Okay, so then I do have a number of links, though, for some further advancements. The first section here are a number of libraries that will allow you to develop command line interfaces much more sophisticated than kind of the ones you saw today. This I think works fine if you've got a dozen or so arguments that are all super well defined, but as soon as we start wanting to get into optional arguments and positional arguments and things like that, we'll want to reach for something a little more powerful. The memfault one is basically probably the next best step to the one the next in complexity. It functions almost the same as what we saw here. It just basically kind of wraps up each of our the commands that we're executing into their own functions, and plugs them into an array, which is kind of a nice way to clean up the code so that I don't have a whole bunch of tendrils in my command processing stuff to all over like global variables and into other modules and things. The args and getopt and gengetopt are libraries that were originally developed for like a command line interface, but it's my belief that you could use those very easily in like an embedded system, as long as, like we saw above, you kind of followed this argc argv style when we were parsing up our string. Additionally, there's a number of architectural improvements we can make to our system. So the first I thought was pretty cool is over wireless communication. So what I've got here is an interface to my Arduino Nano IoT device. And the cool part for me about this was the code that we saw to make this command line interface work is almost word for word on this Arduino right here. I basically subbed out like the serial.available command for like a Wi-Fi.available. But almost unchanged, I can run the same code. I can turn my LED off. I can turn it back on again. I can set the frequency to something rather fast. I can change the duty cycle to something really high. Hopefully you're all seeing that because I'm looking at the back of it right now. Which, so now, this is not just like a wired connection to my device, right? As long as I've got a little Wi-Fi antenna, anywhere I can have this device set up, on my workbench and connect to it over Wi-Fi very easily and start typing commands at it. Okay, additionally, you might think about separating out some of this code so that the command processor is not so much directly controlling like my LEDs, but sort of sending messages so that there's a little more better encapsulation between my modules. I could consider double buffering my system so that I can sort of receive a string at the same time that I'm currently processing one. Additionally, as these get more and more complex, I might have to start thinking about the security aspects of in this command handling code, enforcing privilege levels or logins, or I could even add more robust framing or error checking, especially in a noisy environment, to make sure that those commands are received correctly. I was very careful when I was typing this stuff out because the code we saw also does not do anything if I hit the backspace key because I made an error. It doesn't actually delete anything, right? It just sends the backspace like ASCII code to my microcontroller. So getLine and line noise here are two examples of some ways to implement, some of those backspace characters or left-right arrows or things like that. And then additionally, I mentioned there's a couple of OSs basically that you can put on your microcontroller. So here's some examples of those, and a link also to being able to do the on-chip debugging over the UART peripheral on Cortex-M. So I could kind of like write my command line interface to actually like set breakpoints and single step over code and things like that, like from the UART peripheral, which is pretty cool. Okay, so here's your summary. Like I said, I'm really just doing string comparisons. And from there, I can do a whole bunch of other stuff, leveraging some of the other libraries that that you saw. The slides are available there. I've got a link to all the Arduino and the STM32 code I was showing you on my GitHub, github.com/NathanCharlesJones/simple-CLI. And gosh, thanks so much for being here and hearing me blather, and I hope you enjoy the rest of the conference. While you're here, any questions? Anybody feels like asking before we leave?
So you talked about like adding things like backspace. Do you have are you able to kind of show a quick what is the general approach used to do that sort of thing?
Yeah, absolutely. So let's see. getLine was actually like a piece of code written for a book using STM32 development with FreeRTOS. So this is probably the simpler one. And basically these, you can kind of see here the characters that we're gonna support. They're ASCII codes of some sort. And in this function where we are getting a line, instead of just sort of like previously when there was a serial character available, it just got added to my running buffer. Before we did that, essentially, if we wanted to do something a little more sophisticated, we would say, okay, what character is it? Because if it is the Control U or backspace or whatever, then we'll do some manual manipulations on our string to be able to kind of like roll the pointer back one or delete a character, set the pointer to the start of the string. And if it's not, then down here somewhere. No, so you can, you would do it kind of one character at a time. And at least the terminals that you're using, like a PuTTY terminal, is smart enough that if it receives the backspace character, it knows to like roll back one. So you as a user will see like the character get deleted. And with this code on the microcontroller, then also in the string in memory, the sort of pointer or the string will get rolled back one. Yeah. Readline is a much more robust library. Where'd this go? Excuse me. Nope, I lost all my slides. Okay. Sorry, line noise is much more robust. Actually, readline I think is another one that should probably go on here. This is a much larger. This actually also I think supports like tab completion. Yeah, and like history, so you can like up arrow back to like previous commands. But of course, a bit more robust than just like a 40-line C code or something like that. Right. Exactly.
Yeah, and any change that is created is not modified because otherwise it
do history, you just do the opposite thing. So
Okay. Okay.
Yeah.
turns it back to
Kind of like removing an element.
yeah,
Mhm.
exactly. They have it designated to the side.
Yeah. Other questions?
So, some of the exceeds when they like wake up or they from sleep or when they do that, they have like jump characters in the UART. How do you deal with that?
Ooh, so when an MC wakes up, sometimes there are characters in the UART. So this is like, if I'm on a console and I wake up the processor, I don't necessarily want to see like garbage characters on my display. I don't know if I've got a great answer for that off the top of my head. I'd like to think that there's a way before anything gets sent out for me to make sure that my buffer, my FIFO, whatever is cleared out. The other tactic might be to just expand on the console a little bit, right? So I'm just using PuTTY, right? A little dumb console, but of course I could have written some Python code that just sort of read characters over the UART and printed them somewhere. And so it might be that if, I can, a lot of the stuff, honestly, the whole other tack to doing a command line interface is having something like Python actually read my commands that I'm typing, right? Ask for input from me and I type in a string and then Python does the string parsing. And then what it would send to the microcontroller is like a compressed code, right? Code 47 might mean turn the LED on, right? And so then that can like put some of the resources away from the microcontroller onto the host computer. And so maybe the other solution would be, if there's no way around it, I can have a Python script that would normally just sort of like patch, input and print stuff to the microcontroller, but then otherwise looks for like what would be garbage characters, right? You would look for a specific byte to signify the start of a transmission, and if it got garbage stuff from the microcontroller when it woke up, it could just kind of ignore data until it sees that start character. Yeah, great question. What else? Yeah.
I was going to ask, for recognizing natural characters, are there good examples of like using an enum or some other structure to? Yeah, like what's a good way to go about that so that as you add commands, you aren't cracking back into those if statements to extend them?
Oh, okay.
Like a switch statement?
Well, yeah, that's the easiest next step. But I was wondering, like,
Yeah. So basically I think I want to say all of these CLI libraries. There's a step where you define your command list, and then either there's like a processing step maybe where the software generates a C file and a header file from my command description table description, and I include that into my code so my microcontroller can respond to it. Or sometimes, like in the case of the memfault library, I'm really just sort of like specifying an array, where I say, for this, if the first word matches this sequence of characters, run this function. So really, once we get beyond kind of just our basic if-else chain, all of them have a means of, as long as I make sure there is a unique identifier for each of these commands, the unique function gets run. And that can happen either like in an array that I type in, or in like some pre-processing step where I define this command table. So much more extensible than just like continuously adding an elif or whatever. All right, I think we got a break next. Thanks again, everyone, for being here. Have a great time at the conference.